Welcome to Unacademy and YouTube channel. This is K Umamaheshwar Rao. Detailed solutions of daily practice problems, part 30. Today I will be discussing detailed solutions of daily practice problems which I have shared on 19th October and 20th October. Let me start. First one. Integral 0 to pi by 2. Integral 0 to pi by 2 sine of x plus y dx dy. The double integral 0 to pi by 2, 0 to pi by 2 sine of x plus y dx dy. Now, first we have to integrate with respect to x. Inner integral limits are 0 to pi by 2. 0 to pi by 2 are limits of x. That's why I am going to integrate with respect to x. Now, 0 to pi by 2. Integral sine of x plus y minus cos of x plus y 0 to pi by 2 dy. Now, applying upper limit, we will get integral 0 to pi by 2 minus, I am writing outside, minus of cos pi by 2 plus x. In the place of x, if I substitute pi by 2, you will get cos pi by 2 plus y minus cos 0 plus y, cos y dy, minus integral 0 to pi by 2 integral cos 90 plus y. Cos pi by 2 plus y is second quadrant, that's why minus sin y. Integral minus cos y is minus cos y dy. Now, minus of minus plus, so integral 0 to pi by 2 sin y plus cos y dy. Now, integral sin y is minus cos y. Integral cos y is sin y from 0 to pi by 2. Applying upper limit, minus cos pi by 2 plus sin pi by 2 minus of minus cos 0 plus sin 0. Minus cos pi by 2. Cos pi by 2 is 0. Sin pi by 2 is 1. Minus of minus cos 0 minus 1. Sin 0 is 0. Finally, 1 minus of minus 1, that is 2. The value of double integral is 2. Correct answer is last option. Next problem. Let E is equal to xy belongs to r square. X varies from 0 to y varies from 0 to infinite. Then double integral E y into e power minus of x plus y dx dy. Double integral y into e power minus of x plus y dx dy. Y varies from 0 to infinite, x varies from 0 to y. Y varies from 0 to infinite, x varies from 0 to y. First we have to integrate with respect to x, 0 to infinite, 0 to y, y into e power minus x into e power minus y dx dy. Now we are going to integrate with respect to x, 0 to infinite, y into e power minus y. Integral e power minus x is e power minus x by minus 1 from 0 to y dy. Continuation. Integral 0 to infinite, this minus y into e power minus y. Applying upper limit e power minus y, lower limit e power 0 into dy. Continuation. Minus y into e power minus y into e power minus y, e power minus 2y. Integral 0 to infinite, minus y into e power minus 2y plus y into e power minus y dy. Minus y into e power minus 2y plus y into e power minus y. Now here you have to apply integration by parts. Here we have to apply integration by parts. Now here I am applying integration by parts. Y e power minus y. Differentiation of y is 1. Differentiation of 1 is 0. Integral e power minus y is e power minus y by minus 1. Integral e power y by minus 1 is e power minus y by 1. First term plus, next minus, next plus. Multiply diagonally. Next. Here you have to apply integration by parts. Minus y e power minus 2y. Differentiation of minus y is minus 1. Differentiation of minus 1 is 0. Integral e power minus 2y is e power minus 2y by minus 2. Integral e power minus 2y by minus 2 is e power minus 2y by 4. First term plus, next minus, next plus. Multiply diagonally. Now continuation. Minus y into e power minus 2y by minus 2, that is plus y by 2 into e power minus 2y minus of minus plus e power minus 2y by plus 4, that is first term. Second term plus y into e power minus y by minus 1, that is minus y into e power minus y. Next minus 1 into e power minus y minus e power minus y. Lower limit 0, upper limit infinite. Applying the limits, we will get first, if you apply upper limit minus infinite, e power minus infinite 0, e power minus infinite 0, e power minus infinite 0, e power minus infinite 0. Next lower limit minus of, if you substitute lower limit here, first term 0, Second term e power 0, that is 1 by 4. Next term 0. Next term minus e power 0, minus 1. Finally minus of 1 by 4 minus 1, minus of minus 3 by 4, 3 by 4, that is 0.75. That is the answer. Answer is 0.75. Integral 0 to 1, y to 1, xy sin xy dx dy. Integral 0 to 1, y to 1, xy sin xy dx dy. Now, with the help of limits, first we have to identify the region. X equal to y, x equal to 1, y equal to 0, y equal to 1. X axis, y axis, x equal to y is straight line, x equal to 1, straight line parallel to y axis. Now y equal to 1, parallel to x axis. Here this is x equal to y, x equal to 1, y equal to 0, y equal to 1. He has considered horizontal strip, lower limit x equal to y, upper limit x equal to 1. Now I am going to change the order of integration. Change the order of integration is nothing but changing order of the strip. X axis, y axis. Now x equal to y, x equal to 1. You have to write here in the given integral, it is horizontal strip. We have to consider vertical strip. If you consider vertical strip gives y limits, y equal to 0, y equal to x. When vertical strip is fixed, you have to move horizontally between x equal to 0 to x equal to 1. So y varies from 0 to x varies from 0 to 1. X varies from 0 to 1, y varies from 0 to x, xy, sin xy, dy dx. In the problem, he has mentioned clearly, in the given integral xy sin xy, here also xy sin xy, dx dy dx. So he has changed the order of integration. When you change the order of integration, what are new limits? Observe. Integral, if you compare this integral xy sin xy dy dx, 0 to 1, 0 to 1, a to b. So if you compare these two integrals, we can understand that the value of b is nothing but x. By comparing these two, the value of b is x. The value of a is 0. So a is 0, b is x is the correct option. A is 0, B is x. First option. A equal to 0, B equal to x. Next problem. The value of double integral 0 to 1 x to 1 by x by 1 plus x by 1 plus y square dx dy. The given integral is integral 0 to 1 integral x to 1 by x by 1 plus y square. X and 1 by x are limits of y. That's why dy then dx. First I am integrating with respect to y. Now integral 0 to 1. Integral 0 to 1 x into integral 1 by 1 plus y square is tan inverse y from x to 1 by x dx. Integral 0 to 1 x of applying upper limit tan inverse 1 by x minus tan inverse x dx. Now integral 0 to 1 x of tan inverse 1 by x is nothing but cot inverse x minus tan inverse x dx. Here I have written tan inverse 1 by x is nothing but cot inverse x. Next, integral 0 to 1 x of cot inverse x minus tan inverse x dx. In the place of cot inverse x, you can write pi by 2 minus tan inverse x, because tan inverse x plus cot inverse x is pi by 2, minus tan inverse x into x 0 to 1 dx. That can be written as 0 to 1 x of pi by 2 minus 2 tan inverse x. Tan inverse x minus tan inverse x minus tan inverse x is 2 tan inverse x dx. That is 0 to 1 pi x by 2 dx minus 0 to 1 2x into tan inverse x dx. Here in the first integral we can integrate directly, but here you have to apply integration by parts. X into tan inverse x. So integral u dv form. Observe here. This is called equation 1. In equation 1, integral I am talking about this term. Integral 2x into tan inverse x. I am taking x tan inverse x. U is tan inverse x. dv is x dx. Differentiate u. du is 1 by 1 plus x square dx. v is integral dv, integral x dx, that is x square by 2. Integral u dv equal to uv minus integral v du. Integral tan inverse x into x dx equal to uv. uv. This is u, this is v. So x square by 2 into tan inverse x minus integral v x square by 2 into du 1 by 1 plus x square dx. Integral 0 to 1. Integral 0 to 1. Continuation. Applying upper limit, you will get x square by 2 tan inverse x is 1 by 2 tan inverse 1. Minus 0. Minus 1 by 2. Integral 0 to 1. X square by 1 plus x square dx. Continuation. Observe. 1 by 2. Tan inverse 1 is pi by 4. Minus 1 by 2. Integral 0 to 1. In the numerator, add 1 and subtract 1. 1 plus x square dx. Now, pi by 8 minus 1 by 2. Integral 0 to 1. 1 minus 1 by x square dx. That is pi by 8 minus 1 by 2. Integral 1 dx is x. Integral 1 by 1 plus x square dx is tan inverse x. 0 to 1. Continuation. Pi by 8 minus 1 by 2 into applying upper limit 1 minus tan inverse 1. What about lower limit? If you substitute lower limit anyhow 0. Now simplify this. Pi by 8 minus 1 by 2 plus 1 by 2 into tan inverse 1. That is pi by 8 minus 1 by 2. 1 by 2 into pi by 4. Pi by 8 minus 1 by 2 plus pi by 8. Pi by 8 plus pi by 8. 2 pi by 8. That is pi by 4. Minus 1 by 2. Called it equation 2. Next, you have to substitute equation 2 in equation 1. Substituting equation 2 in equation 1, we get here pi x by 2, integral 0 to 1 pi x by 2, pi by 2 into x square by 2. Zero to 1 minus 2 into pi by 4 minus 1 by 2. Simplify this. Pi by 2 into 1 by 2 minus 2 pi by 4 plus 2 into 1 by 2 is 1. Now, pi by 4 minus 2 pi by 4 is pi by 2 plus 1. Finally, 1 minus pi by 4. 1 minus pi by 4. That is 1 minus 0.785. 0.215. The answer is 0.215. Finally, answer is 0.215. Next column. 1 minus 0.785. You will get 0.215. Now, f is continuous function over the interval xy belongs to 0, 1, 0, 1, 0, 1 cross 0, 1. Then they have given two constraints, x greater than y square, y greater than x square. Then the value of double integral f of xy is y equal to x square and x equal to y square. Here in the problem he has mentioned that x greater than y square, y greater than x square. That means this region, this part, this part. Now this is 0 comma 0, 1 comma 1. Now same region I am taking to change the order. Now I am going to fix horizontal strip. If I fix horizontal strip, lower limit of the horizontal strip is x equal to y square. For horizontal strip, this is lower limit, this is upper limit. Whenever you take horizontal strip, suppose this is horizontal strip, lower limit is this edge, upper limit is this edge. This is lower limit, this is upper limit. Now, that's why x equal to y square is lower limit. Here, x equal to root y is upper limit. This point is 1 comma 1. This point is 0 comma 0. Whenever you fix horizontal strip, you have to move horizontal strip in vertical direction. That's why here y equal to 0, here y equal to 1. Y equal to 0 is lower limit, y equal to 1 is upper limit, x equal to y square is lower limit, x equal to y square is lower limit, x equal to root y is upper limit. Y equal to 0 is lower limit, y equal to 1 is upper limit. Function of xy dx dy. This is the answer. 0 to 1 y square to root y. 0 to 1 y square to root y. First option. Next problem. The value of integral 0 to infinite x to infinite e power minus y by y dy dx. Integral 0 to infinite x to infinite e power minus y by y dy dx. Integral 0 to infinite integral x to infinite e power minus y by y dy dx. Now, if you look at limits of inner integral x and infinite are limits of y. So, it is not possible to integrate with respect to y first. That's why y equal to x, y equal to infinite, x equal to 0, x equal to infinite. Now, y equal to x, y equal to infinite, x equal to infinite, x-axis, y-axis, y equal to x, y equal to infinite, x equal to 0, x equal to infinite. Y equal to x is lower limit. That's why you have to fix vertical strip. Y equal to x is lower limit, y equal to infinite is upper limit. So this is the region. In that region, we have to change the order. Now, I am going to change the order. Y-axis, x-axis, y equal to x or x equal to y. This is the region. Fix horizontal strip. x equal to 0, x equal to y equal to 0, y equal to infinite. Continuation. X equal to 0, x equal to y. Y equal to 0, y equal to infinite. E power minus y by y dx dy. Integral 0 to infinite. E power minus y by y. Integral dx is x. 0 to y dy. Integral 0 to infinite. E power minus y by y dy. Y and y you can cancel. Integral e power minus y dy is e power minus y by minus 1, 0 to infinite, minus 1 of e power minus infinite e power 0. That is minus 1 of 0 minus 1, minus 1 of minus 1 is 1. The value of integral is 1. Next, by change the order of integration in the double integral 0 to 4a x square by 4a to 2 root ax function of xy dy dx can be expressed as integral p to q r to s function of xy dx dy. Then q multiplied with r. What is the result? Now, double integral function of xy dy dx x square by 4a to 2 root ax. Zero to 4a. By using these limits, we can understand that the curves are parabolas. Now, x square equal to 4ay, y square equal to 4ax. 0, 0, 4a, 4a. Now, observe here. dy means they have fixed vertical strip. Now, I am going to fix horizontal strip to change the order. If I fix horizontal, I have to fix x limits. So x equal to here, x equal to y square by 4a. This edge is x equal to y square by 4a. This edge is x equal to 2 root ay. Now y equal to 0 and y equal to 4a. So y varies from 0 to 4a, x varies from y square by 4a to 2 root ay. Double integral function of xy dx dy. Lower limit is x equal to y square by 4a, upper limit 2 root ay. Y varies from 0 to 4a. Now, if you compare with PQRS, if you compare with PQRS, this is P, this is Q, this is R, this is S. PQRS. We have to find out Q into R. Q multiplied with R. Q multiplied with R. Now, what is Q? 4a. R, y square by 4a. If you multiply these two, 4a cancel. The result is y square. Q into R is y square. The value of QR is y square. So, second option. Second option is correct. Next one. The volume of the solid obtained by revolving the region bounded by the curve y equal to x cube and y-axis and the line y equal to 1 about y-axis. So the volume of solid obtained by revolving the region bounded by y equal to x cube, y-axis and the line y equal to 1 about y-axis is. Y equal to x cube. Next, y-axis and y equal to 1. Y equal to 1. Y-axis, this one. So, you have to Take area bounded by y-axis, y equal to 1 and y equal to x cube. This area. This area is revolving around y-axis. That area is the area bounded by y-axis. Y-axis means x equal to 0, y equal to 1, y equal to x cube. Okay. Now, the formula is volume of revolution around y-axis is pi x square dy, y equal to c to y equal to d. In this problem, y equal to 0 to y equal to 1, pi x square. Actually here, y equal to x cube. Y equal to x cube. It is rotating around y-axis. So, y power 1 by 3 equal to x. Because x cube equal to y. Therefore, x equal to y power 1 by 3. So, x square equal to y power 2 by 3. Therefore, I am writing y power 2 by 3 into dy. Now pi into integral y power 2 by 3, y power 5 by 3, 2 by 3 plus 1. So, 5 by 3 by 5 by 3 from 0 to 1. That is 3 pi by 5 of 1 power 5 by 3, 1, 0. Finally, 3 pi by 5. 3 pi by 5 is the answer. Second option. Yeah, around y-axis. That's why I have written pi x square. So, x cube equal to y. So, x square equal to y power 2 by 3. Yeah, ninth problem. By change of variable x equal to uv, y equal to v by u in the double integral, the integral function of xy changes to function of uv comma v u by v, then phi of uv is. If you understand this problem, very easy. Observe, it is a problem designed on change of variable concept. Double integral function of xy dx dy changes to, transforms to double integral function of uv comma v by u. Whenever you are going to change variables from one system to another system, compulsory you have to use Jacobian. What he said? Phi of uv. So observe, he has given that phi of uv du dv. What is this phi of uv? We have to find out. So here x is substituted as uv, y is substituted as v by u, dx dy is substituted as phi of uv du dv. Then what is phi of uv? Whenever you change variables from x equal to uv, y equal to v by u, dx dy will be equal to phi of uv du dv means Jacobian of x and y with respect to u and v. That is phi of uv. Now, Jacobian of x and y with respect to u and v we have to calculate. X with respect to u, x with respect to v, y with respect to u, and y with respect to v. That is given by differentiate x with respect to u, differentiate x with respect to u, v. Differentiate x with respect to v, u. Y with respect to u, minus v by u square. Y with respect to v, 1 by u. Continuation. Find determinant value AD minus BC. That is v by u minus of minus plus uv by u square. V by u plus v by u. That is 2v by u. First option. Now, to evaluate the double integral 0 to 8 y by 2 to y by 2 plus 1 2x minus y by 2 dx dy, we make the substitution u equal to 2x minus y by 2, v equal to y by 2, then the integral reduces to, observe here, integral 0 to 8 integral y by 2 to y by 2 plus 1 2x minus y by 2 dx dy. Now this is the given double integral. This double integral changes to double integral function of uv form. The given substitution is u equal to 2x minus y by 2. U is equal to 2x minus y by 2. V equal to y by 2. Now, first we have to calculate Jacobian. First I am calculating Jacobian of u and v with respect to x and y. U with respect to x, u with respect to y, v with respect to x, v with respect to y. Determine and differentiation of u with respect to x. Differentiate u with respect to x, you will get 2 by 2, that is 1. U with respect to y, minus 1 by 2. V with respect to x, 0. V with respect to y, 1 by 2. 1 by 2. If you calculate determinant value, you will get 1 by 2 minus 0. Finally, 1 by 2. I require Jacobian of x and y with respect to u and v. That's why I have to take reciprocal. 1 by 1 by 2, that is 2. Therefore, we can understand that you can write dx dy in the form of 2 into du dv. By finding Jacobian, we can understand this point. Here, this part dx dy, you can replace 2 into du dv. Now, about integrand, 2x minus y by 2. 2x minus y by 2 is nothing but u. So, here you can write u. Here we can write 2 into du dv. So, limits are left. Now, I am discussing about limits. Now, u is 2x minus y by 2. V is y by 2. Now, if x equal to y by 2, if x equal to y by 2, then u is equal to 2 into, in the place of x, here I am substituting 2 into y by 2 minus y by 2, that is y minus y by 2, that is 0. So u equal to 0. Next, if x equal to y by 2 plus 1, then u is 2 into y by 2 plus 1 minus y by 2. 2y by 2 is y plus 2 minus y by 2. Y cancel, 2 by 2 is 1. Therefore, u equal to 1. Next, when y equal to 0, if y equal to 0, then v equal to 0 by 2, that is 0. V equal to 0. If y equal to 8, then v equal to 8 by 2, that is 4. V equal to 4. Now, double integral. The given double integral changes to, in the place of 2x minus y by 2, we can write u. In the place of dx dy, we can write 2 into du dv. Now, u varies from 0 to 1. Now, v varies from 0 to 4. Now, integral 2u du dv. U varies from 0 to 1, v varies from 0 to 4. That is the answer. V varies from 0 to 1, u varies from 0 to 1. V varies from 0 to 4, u varies from 0 to 1, 2u du dv. 0 to 4, 0 to 1, 2u du dv. Second option is correct. Understood? Understood? This was a 2014 GATE problem. Electrical. In plus courses, we have DPP sessions, weekly, monthly tests, separate doubt clearing sessions, live and interactive lectures, unlimited access by one subscription. Use code KUR75 to get plus subscription. To get iconic subscription or plus subscription, use code KUR75. In iconic subscription for ESE and GATE category, live classes, test series, unlimited practice, structured schedule, personal coach, study planner, experts guidance, ESE mains question and answer practice. Introducing new subscription plan for 18 months for ESE and GATE category, 18 months subscription. Pricing plan 1 month, 3 months, 6 months, 12 months, 18 months, and 24 months. This is my profile in Unacademy Plus. Use code KUR75 to get either iconic subscription or plus subscription. Thank you.